Talking about an isosceles triangle. Basically, the only thing you can know right now probably is two sides are equal, right? Two sides are equal in an isosceles triangle. Let's up that definition a little bit more right now. Not only are the two sides equal, ready? The angles opposite them are equal too. All right, so if two sides are congruent in a triangle, the angles opposite them are congruent as well. Look at your first diagram here. I'm giving you that AB is congruent to AC. Now that you know the angles are equal, which two angles should be equal then? What's across from those two congruent sides, AB and AC? Name the two angles that are across from AB and AC. Let's start this out right. George, what are the two angles?
ABC and AC.
Okay, so knowing the two sides are equal, now lets me write confidently angle B is congruent to angle C. All right, if the sides are congruent, so are the angles opposite. That's the big thing for today. If the sides are congruent, so are the angles opposite. I want to make sure we are clear. It is not always the bottom angles. Please take a look at this triangle I'm just drawing up here now. Let's say I have that. Is that still isosceles? Yes. So the angles across would be equal. So in this case, I would have angle B congruent to which other angle? A. I don't want you always to assume it's the bottom ones. It's not. It's the ones opposite the congruent sides. All right, let's go in reverse now. What happens if I give you the angles are congruent? So B and C are congruent. It's still isosceles. The sides across are now equal. So what two sides would be equal here? 11. If I give you B and C are equal, what two sides must be congruent? Okay, thank you. 22. What two sides must be equal then? AB congruent to AC. If the sides are equal, the angles opposite are. If the angles are equal, the sides opposite are. All right, before I move on, take a look. I'm going to draw two diagrams right now. Okay, take a look. I'm going to tell you AB is equal to ED. Can I use this theorem I just showed you? What do you think? And say that C is equal to F. What do you think? Can I do that? No, I cannot. Because are these two congruent sides in the same triangle? No. All right, everybody. This theorem I'm showing you today only works if the sides are in the same triangle. Good?
Yeah, so that's probably where the word triangle with no S comes from. You know, from the top.
Sure.
Okay.
All right, I'll go with it. Okay, I'll go with it. But in all seriousness, everybody good? The two sides that are equal have to be in the same triangle. If they're not, you can't use the theorem. I can't use it here. All right, vocabulary before we get into some actual problems. I don't want to call the congruent sides anymore. They actually have a name. I don't want to call the congruent angles anymore. They actually have a name. And I want to start using those vocabulary terms. All right, so I'm going to actually bounce around here. Let me start with number 2, the congruent sides. So the two sides you know are equal. We're going to start referring to those as the legs. Those are the legs. The two congruent sides in an isosceles triangle are called the legs. What about the two congruent angles? Base angles. All right, the two equal angles in an isosceles triangle are called the base angles. All right, what about the outcasts? All right, there's one side that's not congruent. A hypotenuse via is only for right triangles. And a hypotenuse is only located in a right triangle, okay? The unequal side, the side that does not match the other two, is called the base. That doesn't equal bottom, though. It's just the unequal side. And then what about the angle that's not equal to the others? Ready? Vertex angle. Vertex angle. All right, so I'm going to call on 4 people right now. And I'm going to go through these terms again, and you tell me what side or what angles I'm talking about. Everyone ready? What is the vertex angle in this diagram right now? The vertex angle in my triangle ABC. Where's the vertex angle located? 24? A, correct. So the vertex angle is angle A. Name the two legs in the diagram. Name the two legs. Now that you know what a leg is. 21. AB and AC. Good. The two congruent sides. Actually, I should just put AB and AC. What is the base in this diagram? 21 again. BC. And name the base angles in the diagram. What are the base angles? 15. Angle B, angle C are my base angles, the ones that are congruent. Good job, everyone. Good work. All right, now let's actually start using this. Okay, I have my diagram. I got triangles within triangles. Everyone see my markings? Which angles are congruent, which sides are equal. All right, I'm going to start off by saying angle R is congruent to what? But I want an angle that's not marked. Yes, I know you could say S. You could say WVS because they're all marked. I want another angle that's not marked that's congruent to R. Take a look at the diagram. You guys don't have to put your hands up. I'm going to call on people with the numbers. Thank you, though. I appreciate it. Okay. Angle R is congruent to what other angle in that diagram that's not marked congruent? Look for isosceles triangles. Look for isosceles triangles that possibly have angle R in it. Angle R, and here we go. What other angle? Do we see anything? 14. Don't have one. I remember that now. 11. Don't have one either. Learn my lesson. 8. Angle R congruent to? Not here. Look at that. We're 3 for 3. Can we go 4 for 4? 23. Angle R congruent to? Angle, well, get a little bit more specific for me, Lucy, because when you say V, I see 3 angle V's. I need more letters than V. That's what I'm saying. There you go. Angle R, V, U. Why? Everyone see triangle RVU? That's isosceles. What's across from the congruent sides? Congruent angles. That's where it comes from. All right, so the Y part, and all I'm doing is getting you set up for Monday because you're going to put this Y in the reasons column of your proof on Monday when we do isosceles triangle proofs. In a triangle. And unfortunately, yes, you do need that. You do need that first part because this theorem I'm showing you today doesn't work in another figure, only a triangle. In a triangle, congruent angles are across from where? Congruent angles across from, you finish it up. Are across from congruent. You could use legs, that's fine. I'll just use sides, that's fine too. Everyone all right? Okay, RT. Find me a side that's congruent to RT. Look what triangle RT belongs to and say, is this triangle isosceles? If it is, find the sides across from the angles. Okay, what do you got? RT is congruent to 20. Side RT and side TS. Just so you know where we're getting everything from. Now we're working with triangle RTS. Everyone see it's isosceles? Angle R and angle S. What's across from angle S is congruent from what's across from angle R, which are TS and RT. And in a triangle, Same, I'm just going to keep repeating this reason. Congruent angles are across from congruent sides. Okay, one more, VW. Find another side congruent to VW. Remember, it's got to be in the same triangle as VW. So look for the congruent sides. Look for the congruent angles. Okay, VW and 8. Nah, I was going to say I had a feeling. 24, VW and WS. Everyone see the triangle we're working in? Right? Again, the Y in a triangle. Congruent angles are across from congruent sides. Everyone, all right, now we're working here because I'm going to let you and your group right now give you about 3-4 minutes. Probably won't even need that much. Might need a calculator for these. Find X and Y in both. It might help. Oh, these sides are congruent. Let me mark the angles that are congruent right away. That might help you. All right, you notice a triangle's isosceles, mark the sides and angles that should be equal. And then try to find the missing degree measures. Go ahead. Give you 3 or 4 minutes to try it. All right, somebody explain to me how you got angle X. Not necessarily what it is, just how you get there. 2, 21, how do we get to angle X?
Because one angle is just 5, and you have the 2 congruent, or 2 little lights, and the other one's just.
Everyone good? Across from the sides are congruent angles. So 55, 55, and then how'd you get to X, Scott?
I added 55 together, and I subtracted from 20.
Yep, so we should get 70 for X. Any issues there with you guys? 70 for X. All right, let's move ourselves up to, now that I know X is 70, how do I get up to Y now? How do we get to Y? Let's go with, Scott just went. Let's do another one here. 24, Romeo, how'd you get up to Y?
Since X and then the vertex angle of the other triangle are like vertical angles.
Yep, good.
That's going to equal 70, and then the difference is divided by 2.
Good, and then now on this isosceles triangle, I know this angle and angle Y are equal. So I take 110, the remaining angle measure, cut it in half, and I should get 55. We okay getting there? Yes, Via?
No, I just want to answer the second one.
Okay, I'm still going to call on people here.
Okay.
Okay, so I got 110. That's where I started from, and I somehow had to get to X and Y, whatever one you found. It didn't matter the order. All right, so let's talk real quick. 14, 2. If that's 110, what was the angle next to it? Or just however you found it, Karen. I don't care. However you found it.
Oh, sorry. Wait, angle what?
I was saying this is 110. Did you find the angle next to it?
Oh,
Or however you found X and Y?
it's 90, so you do.
The angle next to it? This angle right here is 90?
No.
Okay, that's the angle I was asking for, but
I don't know, I didn't get that.
okay. Do you remember what these two add up to at all? They're right next to each other, form a straight line.
100.
I got what do straight lines measure? 180 degrees. So if that's 110, this is going to be 70. Everybody good here? All right. You could take that, or you can go somewhere else now to get X or Y. 23. Where else do we want to go? Lucy, where else? What type of triangle is the big one?
Wait, is that X or Y?
No. I'm just asking a general question. I'm not asking for X or Y. What type of triangle is the big one?
Isosceles.
Isosceles. So do you see the angles across from the congruent sides? 170. So what's got to be X? 70. So everyone good there. The big triangle was isosceles. So those angles are congruent. If 170, the other 70. All right, where can I go from here now to find angle Y? You don't need to use isosceles triangle to find angle Y. All right, you could just use 180 degrees in a triangle. 13, where can I go to find Y? Is there one here today? 13?
Wait.
Sorry, Cal. I'm just looking for how do we get to Y?
You gotta use the 270s and like subtract from 180 and you get 40. And then divide that by 2 to get 20.
Okay, so I get 20 degrees that way. Or if you did it this way, right? Yeah, I know 90 and 70 add to 160. So that means 20 degrees left over for Y. Either way. Yep. Yes.
Would it fine if you did it the other way, where like where you took the 90 and then you did and then like wait you took the 90, you subtract it from like 110 to get like 20 because
So the exterior angle stuff?
Yep.
No, the third way. Yep, you got it. Okay, Chromebooks out. We're reviewing as a class, not individually. We're reviewing as a class. Get the review up, please. Wednesday, cumulative 1 quiz coming up. So it's up on Classroom. Remember the link. We're going to go right up to the bell. So plenty of time to practice together. All I'm going to do is I'm just going to get a random number between 1 and 40. We'll do that problem together. Just keep grinding until the bell rings. So calculators next to you, wherever you're keeping your work for all of this, please have it out. Okay, are we ready? Here we go. As many as we can bang out here until class is over with. Let's start with 15. Not number, like question 15, not person 15. So take a look at 15. I'll cut it out myself and put it up on the board. And then we'll start. I'll also have questions for people too, still. Oh, look at that. Perfect. It's the unit we're in. Okay, question 15. I'll let you guys read through it too. And then I'll start asking people questions. Looks like I have some information that's given. Okay. What's up, Jackson? Did you go on Google Classroom and do the link from there? Nobody else having an issue? Okay.
Like Google, like go on their website.
No, just okay, typing in front of it.
You can try and I haven't
All right, let me ask you guys a couple questions. Ready? So you got the sides. You have the sides congruent. Name something else you can mark on your own. You don't need a given to. What else could you mark congruent on your diagram? This may take me a couple times, but we'll figure it out. Of course. Come on. 16. What else could I mark on my diagram congruent?
Oh, you can mark the AN and SC as parallel.
No. I'm not going. What else? I don't even know this right here.
Oh, okay.
I don't even know any of this other than AN congruent to SC they gave me. What else could you mark if this was approved?
And SKC.
They're vertical. Everyone agree? All right, so what do I have so far? I have one pair of sides and I have one pair of angles. And I need angle, side. So what's the only thing I'm missing? One more pair of angles. Everyone see that? The only thing I'm missing from angle, side is a pair of angles. So I need to figure out which one of these three is going to give me a pair of angles. Bisect each other. Is that going to give me a pair of angles? No, that's going to give me a pair of sides. K is the midpoint. Is that going to give me a pair of angles? Pair of sides, correct. AS perpendicular to CN. That'll get perpendicular lines will give me what type of angles? Right angles. Here though, I don't need them here, right? I already have that. So why is AN parallel to SC going to be the one? Because they'll give me what type of angles here? I'm going to get fired up here in a second. 10. What type of angles are they going to give me? AN and SC. Alternate interior. Whether it be A and S or N and C. Okay, and that will be angle, side. All good? Okay, let's keep grinding. Next one up. Let's hit up. No, I think we did. Most of us did 2 already. So let's keep 8. I don't know if any of us have moved that far yet. If you did, congratulations. Here we go. 8. Jackson, any update? Okay. There you go. Thanks, Lisa. You guys read through it. I think we got to have a diagram for this one, pretty sure. So I got triangle ABC. So hopefully we got a triangle working for us. Triangle ABC. And then it tells me CAB is 2x. ACB is x plus 30. If AB is extended through point B to point D, so I'm going to make AB longer, right? That's what it'd say, extended out to point D. CBD, everyone, is CBD inside or outside the triangle? Outside, yep, right here is 5x minus 50. What's the value of x? This is this unit, isn't it? Something we've done this unit. Something we've done. Set up the equation for me now. Okay, what's the equation going to be using our exterior angle theorem? 8, again, 8. We don't even have one here today. Come on, I'll be patient now. 13, got an equation for me I could set up. Exterior angle theorem.
2x plus x plus 30 equals 5x minus 50.
Good work. Exterior angle is equal to the sum of the two remotes. That's what we went over this unit. Good work, good work. All right, go ahead and solve for x. I don't need to hold your hand for that one. And we end up with 40, I hope. X equals 40, perfect. I'm gonna keep grinding along here. All right, let's go to problem number deep 32. This is too easy for some of you, I hope. And that's the way the quiz will be. Some will be very easy, some might take you a couple minutes. All right, what am I dealing with here? Just tell me the whole story here. What am I dealing with? 13. I already heard from Callum. We're going to want to hear from somebody else. 15. What are we dealing with here?
Those two are vertical.
Yep, go ahead. Keep talking.
So you get 7x plus 16 equals 3x plus 140.
There you go. Done. All right, guys, done. Knowing they're vertical. Eight. X equals 8.
Yep.
We're all good. Vertical angles congruent. No issues. All right. I don't want to spend too much time on that.
Yep.
All right. Let's roll with 14. What's this one look like? Oh, equation of a line. Perfect. Definitely need some help with those. We are on question 14. 14. All right, so just a reminder, if you're going to write the equation of any line, you need two things. You need the slope and you need the y-intercept. If you're going to write the equation of any line, slope and y-intercept. So let's start with the slope. It tells me here that these lines are going to be parallel, parallel, parallel. Do we remember anything? If two lines are parallel, what should I know about their slopes? 23?
They're equal.
They are equal slopes. Equal, good. So if I look right up here, y equals 2x minus 8. What is the slope of that line in that form? What's the slope of that line? 1, George?
2x.
2. Oh, no, don't. Watch your mouth. No x. Just 2. Okay, just 2. So the slope's 2. Y-intercept, here's how we found it. You use y equals mx plus b. You plug in for y, m, and x, and you solve for that b. All right, somebody's going to help me do that. 5. We don't have one, right? We definitely don't have a 40, huh? 16. Ready? What's a y coordinate this line goes through? Negative 3. What was the slope we already determined? 2. What's the x coordinate it goes through? 0. And then I'm going to solve for b, everyone. Negative 3. 2 times 0. 0 plus b. Move the 0 over, however you do it. What's going to be my y-intercept? -3. Let's put the two together. What's my equation of the line? Put the two together for me. 8. 24. Romeo, equation?
Y equals 2x minus 3. Which is
There we go. So you got to find the slope. You got to find the y-intercept. That's how we find the y-intercept, by using y equals mx plus b and plugging in the point they give me. Any questions? You'll see there's a lot of those on the review, huh? Maybe it'll come up a lot on the quiz next week. 21, here we go. Problem 21. What are we looking at here now?
Oh, okay.
Oh, little parallel lines. Look at, we're all across the board today. Little unit 3 here for you.
wait, 21.
Oh, it's 21. Sorry. I got all fired up.
It's okay.
Oh, now I'm all,
Now you're disappointed.
no, I'm just all, I can't. How do I get rid of this now? Oh, there we go. Oh, geez. Numbers in a ratio.
Now you're disappointed.
Relax. All right, 2 supplementary. All right, well, I'll start right there with somebody. What's supplementary mean? These 2 angles are going to do what here? Supplementary 14. These 2 angles are going to. You could talk with you. I actually get a number. It's George, going to you. These angles are
Equal 180.
equal 180, right? 2 angles equal 180. If I have numbers in a ratio, what do I use with the 3 and the x? I put what with them to put in the equation? The 3 and an x, attach a, this kid here. Ooh, we're good. 22, attach a to the 3 and the 6. 22, anybody?
Oh, you.
Hi. 3 to 6. I can't put a 3 and a 6 here. That doesn't make sense. 3 plus 6 equals 180.
We multiply them
By what?
by one of the numbers that you've given.
And this isn't a guess and check deal. I can find that number pretty quickly by putting what with the 3 and the x.
Multiply them by 2.
Okay, I multiply them by 2 and I get 6 and 12. That doesn't equal 180. What I'm saying is stop using the multiple choice. I want to figure out the answer right away. So instead I put x's with them. That'll tell you, that x, Aiden, is going to be what you multiply by. Are we good? Because I take away those multiple choices on you, you're going to be guessing and checking for a while. See what I mean? Everybody else good? 9x equals 180. X equals 20. They sucked you right in. Pick me, pick me, pick me. That's what they're doing. Because you didn't read the problem. Not looking for 20. I'm looking for the smaller angle. So what do I need to do with 20? Plug it into which one? 3x. Yeah. Welcome to the Regents exam in June. They're going to suck you guys right in. Oh, you got x. I'll put that as an answer, even though I didn't need it. We all good? 45. Yeah, we're grinding. We're grinding. Let's go. Next one up. 16. What do we got for 16? Hopefully a quick one here. Oh, there we go. Parallel lines. I knew I could get one. Let's see if we can get it in here. I think we can. All right, I'm going to talk here because I have about 30 seconds here. And you guys can finish it if you need to. TVQ 5x minus 22. VWS 3x plus 10. Bottom line is, do we know what type of angles they are or not? They're okay, they're corresponding. Second problem is, are they supplementary or congruent? They are congruent. 5x minus 22 equals 3x plus 10. All right, corresponding angles makes them congruent. All right, I'll see you guys on Monday. This will be on Wednesday. Good work today. Have a good weekend and behave. There's still work out of the textbook on isosceles triangles.